Have you ever wondered why your coffee only cools down? Why broken glass never leaps back together? Or why, no matter what you do, tomorrow always lies ahead, not behind? It feels obvious, but behind this everyday truth hides one of the most unsettling mysteries in all of physics. Why does time only move forward? The laws of physics don't care about time. At the smallest scales of reality, particles don't seem to care which way time flows. An electron behaves the same whether it's zipping into the future or rewinding into the past. The fundamental equations of physics are, as scientists say, time reversible. Yet our world stubbornly marches forward. Eggs break, stars burn out, and each of us grows older. So what's forcing time to pick a side? Entropy, the invisible sculptor of time. In the 19th century, physicist Rudolf Clausius stumbled onto something profound: entropy, a measure of disorder. Picture a perfect cup of coffee, dark and smooth. Now pour in some cream. At first, beautiful swirls of white dance in the black, but before long, it all blurs into a bland, uniform brown. The universe, Clausius realized, behaves just like that cup of coffee. Entropy always increases. This relentless rise of disorder is what physicists call the arrow of time. A universe born in improbable order. But here's where things get truly haunting. If entropy keeps growing, then long ago it must have been incredibly low. And indeed, moments after the Big Bang, the universe was astonishingly ordered. A smooth, balanced cosmic canvas. But why? Why didn't the universe start off as pure chaos? Why was there order to lose in the first place? Wild theories, timeless universes, and cosmic foam. To explain this cosmic puzzle, some scientists suggest the universe itself creates entropy as it expands, like paint spreading across an ever-widening canvas. Others, like physicist Julian Barber, propose something more radical. Maybe time doesn't exist at all. Imagine reality as an endless film reel of frozen frames. Past, present, and future all exist simultaneously, but we, as conscious beings, only experience them in order, giving us the illusion of time flowing. And then there's the multiverse idea, that our universe is just a single bubble in an infinite cosmic foam. Perhaps most universes began in high entropy and never had time as we know it, and ours is just an incredibly rare exception. When time runs out, each theory offers glimpses of an answer, but none unlock the full mystery. What we do know is this: entropy is patient, unstoppable, and it wins in the end. One day, trillions of years from now, stars will fade, black holes will evaporate, and the cosmos will reach its final silent equilibrium. No more heat to spread, no more events to unfold. Physicists call it heat death, a moment when time itself loses meaning because nothing ever changes again. A mystery still unsolved. For now, though, the cream still dances in your coffee, the sun still rises, and time carries us forward, one heartbeat at a time. The arrow of time remains one of the deepest mysteries of our universe. Somewhere, hidden in swirling equations of entropy or the mind-bending landscapes of timeless reality, lies an answer. And maybe, just maybe, one day we'll discover why. Take a look around. The stars overhead, the ground beneath your feet, even your own heartbeat. All of it exists because of a cosmic twist of fate. According to the deepest laws of physics, our universe shouldn't look anything like this. In fact, it shouldn't exist at all. The universe's missing twin. Every particle that makes up our world, protons, electrons, even the atoms in your coffee cup, should have been perfectly matched by an antimatter twin. An antiproton, positron, and so on. And here's the catch. Whenever matter and antimatter meet, they obliterate each other in a flash of pure energy, leaving nothing behind but light. If the universe had stayed perfectly balanced, there would be no planets, no stars, no life, just an empty darkness sprinkled with a fading afterglow. But somehow that didn't happen.
1 in a billion, the lucky imbalance. In the first microseconds after the Big Bang, the universe was a blisteringly hot storm of particles and antiparticles, popping in and out of existence faster than thought. And yet, for every billion matter-antimatter pairs created, there was one extra particle of matter that had no twin to annihilate it. 1 in a billion. From that tiny leftover came everything: galaxies, nebulae, planets, and you. But why did the universe favor matter, even by such an absurdly small margin? The broken symmetry.
To uncover this cosmic mystery, scientists had to explore the very fabric of reality. In the 1960s, Soviet physicist Andrei Sakharov proposed that 3 special conditions might have tipped the scales. 1. Matter and antimatter had to behave differently, a violation of what's known as CP symmetry. 2. The universe needed to be out of equilibrium, an unbalanced, chaotic state in those first fiery moments. 3. And finally, there had to be processes capable of turning these differences into an actual excess of matter. It sounded almost elegant, but proving it? That would be anything but simple.